Hello and welcome back to the shop, and today is Wednesday, our follow-up video of the making of the piston rod for the Baker steam traction engine. So on Wednesday's follow-ups, we answer all the viewers' questions and comments, or as many of them as we can, in a short amount of time, so let's get into it. So many of you had commented on the beauty of the old Monarch lathe here. This is a 1945, June of 1945 Monarch 18CU. Absolutely love this machine. This is actually the second Monarch I've ever owned. I had a 12𝐶𝐾. If you go back in the videos, I sold that about a year ago. And I also had a 25N that I sold a few years ago. And I had a 16CY that I sold as well. So I'm down to just the one Monarch. This is well suited for the sizes of everything I do, 18-inch. I don't do a lot of small stuff, so this works out amazingly well. And then I got the Lion for the bigger stuff, but absolutely love this lathe. Been a great asset here in the shop. So, into the first questions. Somebody asked, would it help to put a couple of wrench flats on the crosshead and to help hold the shaft when tightening the nut? No, I don't want to do that, and the reason is I can just keep the cylinder head off and hold the nut on the cylinder head and tighten that nut. So not a big deal there. Adding wrench flats was not something that was ever done from the factory, and generally when there are pipe wrench marks on a shaft, it's because somebody didn't want to take the cylinder head off. Here's one, guessing the chrome is harder than the base metal, and how thick of a layer is it? So yes, the chrome is much harder. It's a very smooth, polished surface for use with hydraulic cylinders. The chrome is about 5/10 thick, so it's not very thick. It adds about 1/1000 total to the diameter of the rod, so it's not very thick, but it is very smooth, very hard, and it works extremely well. That's why we use it for hydraulic rods, and now in this case for the cylinder rod. So another really good question that I've had a few times here was about the threads in the crosshead. Why I chose to thread a little bit deeper for the rod versus cleaning up the threads in the crosshead. And the reason for that is that's still original, untouched. I don't want to screw with the crosshead. The threads were excellent in there. The reason why it was a different thread, or not so much a different pitch, but a different diameter, is when this was built in 1917, there were not standards that there are. Well, standards didn't really come into play until the 20s, 30s, and especially with steam engine design, around 1920, 21, somewhere in there was when the ASME got in on the boiler stuff. So I don't want to screw with the crosshead. I just didn't want to screw with it. Leave it alone. You run the risk of, run a tap in there or something, you run the risk of doing damage. And I just wanted to leave it alone because it was perfect. So we just make the rod to match that. Nothing wrong with that. It's a good way to approach a lot of things like this that are irreplaceable or not easily repaired or something to that effect. Just if the threads are good, just make the mating part to match. So another really common comment, and don't comment on the lathe being dirty. I just finished something yesterday and I just I gotta clean it off. Not a big deal, but don't worry about that. This is a working shop, not a hobby shop. So a lot of comments on how does the taper attachment work. And I have other videos showing this in more detail. It's a very simple process. There's a slide bar under this cover here that there's a piece that rides in it with bearings, and that actually shoves the crossfeed nut. So the screw and nut are attached, the nut is attached to this bar, and that adjusts the location. So it just pushes the cross slide back and forth, but you have to lock the drag thing in. So you lock this thing down and it holds that bar stationary, and then the bar with the bearings that's in the end here slides up and down that, following that track, pushing the cross slide. So very simple setup, very well built on these Monarchs. There is no better taper attachment in the world than what's on a Monarch. I've used several different ones over the years. The Monarch is by far the smoothest there is, especially if you keep your bearings adjusted properly or replaced them as needed. When I got this, the bearings the first thing I did was replace the bearings in the in the bar, the guide bar, or block, whatever you call it. It's got a name, I'm sure. But replaced the bearings in that, set them up properly so they were locked into that groove nice and snug, and no issues whatsoever. This thing's just flawless. So if there is an older video on this, go back to my channel and check out threading or tapering. There's a few videos with taper cutting, and I show the taper attachment in a little more detail. Well, I hope you enjoyed the video. And stay tuned, there's a lot of cool stuff coming, and also don't forget to check out my older content. There's a lot of great stuff there. As far as cool stuff coming, we are putting 3-phase power to the sawmill shed. That video is coming up, and we also have the reveal of the top secret project coming up. So we're going to be shooting that video today, Wednesday, when this video is out. We are shooting that video. The reveal, and I don't know if it'll be this Saturday or the following Saturday, but we're going to get that video done and out, the full reveal of the top secret project. And this is a big project that's going to be coming up, we're going to do this winter. So stay tuned, a lot of cool stuff coming between the sawmill, the steam engine, the dragline, you know, just in the shop in general, just some neat stuff we're working on. So stay tuned, thanks for watching. And I hope you enjoyed this. I hope I answered all your questions. And until next time, get out in your shop and get it done right the first time.